Ladies and gentlemen, so today what we're going to be working on is a gizmo, and our gizmo today is on energy, specifically mechanical energy. So if you guys want to open up that gizmo, I do want to do part of it together. So if you guys want to open up the gizmo, and it looks something like this. And so I want you guys to come up with those definitions, either from your POGIL, maybe you just know the definition, maybe you have to look it up on the internet. Find those 4 definitions for me. Take a couple minutes to do that. So get all 4 of those definitions down. Take about another minute and a half to get those 4 definitions down. All right. So can anybody tell me what the conservation of energy is? Anybody know? Nobody has a definition for the conservation of energy?
It's when energy can't be created or destroyed, so nothing's changing.
Perfect. Energy can't be created or destroyed. Has to remain constant. I can spell constant. So which means energy is going to be transferred from one thing to another, or one form of energy to another form of energy, but it doesn't just go away. And we have this gravitational potential energy. And what kind of energy is that? There are going to be two key words for that one. There's gravitational, which tells us one thing, and then there's going to be potential, which gives us the other part of our definition. What is gravitational potential energy?
The energy stored in an object.
Perfect. The energy stored in an object. And so gravitational potential energy is going to be specific to or as a result of the object's height. So I'm going to put that in there. A result of the object's height. So we care about the height that the object is at above the ground. That's going to give us our gravitational potential energy. What about our translational kinetic energy, or our K, our kinetic energy? What kind of energy is that for? What is kinetic energy?
The work required to accelerate from rest to its given velocity.
All right, so it's the work required to accelerate an object from rest to its given velocity, or it's our energy of our motion of our object. And mechanical energy, what is mechanical energy going to be?
The energy of an object due to its motion or position.
Energy. All right, and so real quick, I want to look at mechanical energy. So mechanical energy says it's the energy of an object due to its motion or position. And we know that the energy of motion is our kinetic energy, and the energy of its position is our gravitational potential energy. So really, this mechanical energy is just going to be the sum of both of those two. So it's going to be our gravitational potential energy and our kinetic energy. So it's going to be both of those things combined. All right. So it says in the prior knowledge questions, it says below are two images of toy. One is a toy car about to roll down a track, and the other is a pendulum bob about to swing. At what point do we think the car and the bob will reach their greatest speeds? So where do we think on just this wonderful picture, the car is going to have its greatest speed? Where is it going to go the fastest?
As soon as it gets out of rest.
As soon as it gets out of rest, so right here, it's going to be the fastest.
Yeah.
All right, everybody else agree? Anybody disagree? All right, everybody agreed there. All right, what about the pendulum?
Right before it like passes the middle.
You're saying like right here-ish?
Yeah.
All right. So in this gizmo, we're actually going to figure out if we're right for both of these. So we're going to see if we're correct throughout this gizmo. But what is alike about these two situations? So what do we think is going to be the same about these two situations here? Anything that we think is going to be the same between those two things?
What with what I put, what I saw was similar is that it's like greatest speed when it's falling.
All right. Speed is greatest. And falling. All right. Anything else somebody else said? Everybody agree with that? Anybody have anything else they wanted to add or subtract? Adjust? Are we all good with that?
These also involve the objects going like up and down.
Both objects move up and down. Awesome. Anything else we wanted to add here? All right, so then down here, what we're going to be doing is using this gizmo. It says objects have several types of energy, potential energy. We're calling it gravitational potential energy since we know there's two types. There's gravitational and spring potential energy. For this, every time they say PE is going to be representing their U. So it's an R. PE is how they write potential energy. We write it as U sub G for us. This is just talking about gravitational potential energy. And that depends on the object's shape and position. And then kinetic energy is the energy of its movement. And they write their kinetic energy as KE. And we always write ours as just K. They're the same thing. And so the energy of a pendulum gizmo allows us to explore about the amount of these types of energy during the changes in the pendulum's motion. So what you're going to do is you're going to be working through and changing all this information. So if you go to the actual lab, if you open it up in Gizmo and you log in, you got to log in. Yours will get to your class, which is right there for me. We launch that. And we log in. We'll start with this information up on the left side. That information should be what you start with. You're going to adjust your angle to be at 40. You can move these things with the slider, so you can change where you start. You can change this information. You can change this information. You can change the acceleration due to gravity. And then up at the top is where you're changing to look at the bar chart. You're looking at the table. You can look at the graph, whatever it's asking you for. And then you'll just click play and you'll watch what happens when the pendulum swings back and forth. You guys have today to work on this. It shouldn't take terribly long, but he might roll into a little bit of tomorrow, depending on how much time it takes to get through each of those problems. If you have questions, let me know. Otherwise, you guys don't have to stay to work on this gizmo. I'm not going to make you stay here. But if you are looking for your login information for the gizmo, it's either on the classroom resources. There is a link to all the logins with their usernames and passwords, or I have my gizmo up. I can get your login information and I can tell you what it is if you don't remember it.